Hello. Okay, we're ready to get started. Welcome to the Friday Transportation Seminar at Portland State University. On behalf of Dr. Robertini, I would like to invite our today's speaker, Steve Perone, back to Portland State. Steve is an alumni from our business school at Portland State. So he's now the president of PTV America. PTV, as many of you may know, PTV is the provider of a widely used suite of software for transportation modeling and simulation. So for today, Steve will talk about to improve analytic efficiency through the integration of simulation and modeling tools. With that, I will give the control to Steve.
Very much. It's been a while since I've been in the classroom. So.
We're going to stop for an hour.
Support those functions. So let me show you a little bit about where we're taking the technology relative to real time.
Steve, you need to turn your mic on.
Oh, okay. Sorry. Can you hear me better now? At least on the internet, I guess. Yeah. So, all right. So we PTV have been in business since 1979. Our company is founded and still headquartered in Karlsruhe, Germany, which is where most of our software development occurs. Since that time, we've expanded to have 12 subsidiaries operating across 12 continents. So, we've found a relatively successful business model for what we consider planning, the traditional planning space, municipal, city-type planning, as well as logistics, where we support business-to-business type applications as well. So traffic software is what I'm here to talk to you about today. And for us, that is really represented by what we call PTV Vision, which is our VISUM and VISUM products at the heart. We've expanded that a little bit with some traffic engineering tools like PTV Vistro. And we've created some derivative products because we are a multimodal software company. So we have pedestrian software in our VISIM program, but we've specialized that for architects or people that want to just study pedestrian movements with features that are provided through individual products like VisWalk. I mentioned our future. So, we believe that real-time technology is, the heart of traffic management centers and helping cities operate better. And so we are introducing some newer products to help with those challenges. So I'll show a little bit about that here as I move through my presentation. So this is a 10 or 15 second video from our VISIM software, and I show this because this was the first project that I worked on in Salem, Oregon, that exposed me to simulation modeling and VISIM. At the time, the project was called HPTC, High Priority Transportation Corridor Plan. The goal of this plan was to demonstrate that we could improve transit service without degrading automobile service at the end of the day. I'll talk a little bit more about this project throughout the rest of my slides, but I guess I wanted to give you a little of my background and what got me excited about this field and why I'm with PTV today as well. So what are multi-resolution modeling? What does that mean? In a lot of cases, that elicits the idea of tools or methods. But to me, what I think is most important, really, I think of geography, right? Scale of resolution. So when I talk about macroscopic models, those are regional models. How do cities interact together? MPO-type models. Mesoscopic models are typically for us corridor models, right? Focus interaction between or among cities or facilities. And microscopic modeling is actually focused on facility operations themselves. I think the other thing that's a key differentiator or component relative to modeling at separate resolutions is the time scale. So in a regional context, we might be looking at a day or a PM peak hour, an AM peak hour, or hours, typically. In a corridor plan, we might be really looking at intervals within the hour, right, or the peak 15 minutes within an hour. And at a facility focus, we're really looking at seconds, right? How do cars accelerate and decelerate and the impacts of that. So multi-resolution modeling itself, though, is how do we tie the components of these individual levels together, right? And so on the left side, you know, sort of the Venn diagram is trying to pull together what pieces, because each level supports some level of design, some level of modal analysis, and some level of scenario screening, right? So that is sort of in a nutshell what we're trying to do by stitching together these time resolutions and spatial resolutions to analyze each of these elements with consistency. So what are some of the benefits? So I've listed 4 here. Data access, I mentioned consistency, level of detail, and resources. So just expand a little bit, an example. We talk about level of detail. So we might be looking at a corridor study, and in that corridor study, maybe we're studying freeway operations, and really we're trying to figure out merge and weave behaviors. But at the end of the day, we're in a corridor, and that corridor is also supported by transit service, right? So we want to know, or at least be informed by the influence that the transit service is able to provide relative to the demands in our freeway system, right? So what are the keys to success? So I think you need a data model that can support working at different resolutions. You have to be able to have support the correct level of detail, whether that's time or modal operations. And you need consistency both vertically and horizontally at the end of the day. So whether that's consistency with plans and assumptions, such as land use or travel making, and across the and up and down relative to perhaps mode shares. Okay, so those are sort of that's the framework of the car, and now I talk a little bit about how our tools give you the keys to the car. How can you achieve some of these types of things with our tool set? So I showed you a little video, and probably most of you are most familiar with our VISUM application, which is our simulation tool. But our PTV Vision software at the top level is made up of VISUM. And really that is the glue that sort of holds together or supports being able to work with data sources, and integrate components further down the time and geographic scale resolution. So I thought maybe the best way to illustrate some of that was through some use cases that illustrate the different functionalities expressed here through a series of questions. So the first one is, can I work with travel demand model data? Duplicated. And yes, you can. So PTV Vision is a travel demand modeling platform itself. But I think the important thing to recognize here is that it is also, it supports methods itself, but we also interface with common competitor software or other software in the industry as well. So you don't have to have your travel demand model in our software to take advantage of the features of our software for your applications, especially as they move downstream within our software. So integration with other data is, of course, critical. And more data is coming available every day, right? So maybe some of you have contributed to OpenStreetMap in one form or another. We integrate directly with OpenStreetMap, so you can use this for background images, or you can use it as a data development tool and extract elements of the network and use it directly within our planning tool. We also support integration with commercial data like Bing Maps. So, if you're, wondering how many lanes are on a facility or if there's crosswalks or other things, you can easily get to that type of network supply type information anywhere in the world. The other thing that starts to then become important is the level of detail, right? So an OpenStreetMap network is a connection of nodes and links. It doesn't really know that much about the geometry of an intersection. So we have interfaces. Our data model is set up so that it can handle intersection level geometry. So turn pockets, turn lanes, crosswalks, signal control. So once that data is integrated, you can start to get some level of statistics. So at the top level planning model, we might be talking about volume to capacity levels on links. And in some cases, that might tell us we have values that exceed 1. Well, when we're at the intersection level here and are at a level of service, we can still exceed capacity, I guess, in that context as well. But in the framework of simulation, you really can't, right? So you never exceed capacity at the end of the day. So we have screening tools to help you judge how your data is set up and whether it's effective or whether you'll experience problems and where those might be. So relatively easily, you can go from a static operational model to a dynamic model where you're moving cars with signal control and evaluating, queue lengths or other things relatively straightforwardly. So can I work with big data? Or what is big data, I guess, even in the concept of transportation now. So I guess I would frame a little of this context, again, around network supply. And working with things like commercial navigation networks. So we support partnerships with the major commercial navigation providers. So those are TomTom and Navtech or HERE. And these data providers, they're assembling billions of data points every day, from multiple sources relative to people using the roadways and their representation of the roadways. And They organize this data in a variety of formats, but one of the most common is what's called TMC codes, traffic message channels, which are used a lot in the radio or broadcast industry for reporting traffic. So by interfacing with these data codes, you can interface with data like INRIX, for example. And so here is a sample roadway segment that is represented by a TMC code, all the red area. So we can get speed data from commercial providers to tell us how this facility is performing. We also know that that's a pretty big section of roadway, and depending on the level of analysis we're looking at, whether it's the curvature of the road or the approach to the intersection, that might be too much detail as well. So you can see that these segments are also represented by much smaller roadway segments by the navigation system providers. And there's data available for both of those types of scenarios. So you can get aggregated data that's compiled across these segments, and you can get data that varies on the individual segments. So depending on what and how you're doing, you can use either source to your advantage. So the other thing that we're typically doing is interfacing this data with some of our, you say, ground truth. Typically that's, traffic counts collected by the city or the state. And what we do is organize those in the same frame so that you can not only be working with speed data, but you're working with volume and count data as well, all in the same interface. So can I add detailed network geometry and control data? Well, you've already seen a little of that, so I've already answered that question itself. But the thing that I wanted to highlight here is that it's consistent across all of our tool sets, the geometry and particularly the control. So if you've entered signal timing at our top level model, you can use the same signal control data in our simulation model. So there's leveraging of the data sources themselves. Here's an example of the signal timing interface. So time dynamics is also the other thing that's pretty important. And here I'm going to show just a sample of a time dynamic model that was used for evaluating the Olympics and people leaving event venues at the Winter Olympics in Vancouver a few years ago. The important thing about this particular set of images is that this is a time dynamic capacity constrained assignment that is using a linked node structure. So we have time dynamic assignments that conform to traffic engineering theory, and these can also be extended to incorporate things like, in this case, we're applying this for pedestrian movements. So we're not actually looking at vehicle movements in this particular case, as people exit the Olympic venue and are actually, in fact, destined, mostly in this case, for transit service, indicated by the black checkered lines. So you see the densities, the spreading out of the traffic, and the queuing that results on a linked node basis. Again, the important thing relative to this is that we can seamlessly move these and convert these into vehicle inputs and routing decisions for our simulation tool. So data fusion is also a pretty important topic relative to working with all of these data sources. So here I have a network model for Portland, and this is a commercial navigation network, in fact, NavTech. And all of the blue dots are actually the TriMet stations that have been provided based on the general transit feed specification or the Google Transit feed specification. So underlying this network, we have the complete timetable of the transit system integrated directly on the street network. A little harder to see, but this network also is integrated with trail systems. So in Forest Park and other places, we've taken data from, in this case, OpenStreetMap and combined that with data from Navtech where we didn't have data on trails and bike paths. Oops. Excuse me. So this is what I would term supply-side data fusion. I think the other component of data fusion that is critical in working with in transportation is demand data. So we have a suite of tools which the family of tools are basically considered ODME, or origin destination matrix estimation tools. But the important thing is that the tool set itself gives you a lot of parameters to work with so that you don't over-distort your data. Right? So I'll give you a little bit of an example. So, and whether that's working with turning movement data or trip length distributions, or whatever the sources of data that you're working with contain, if you're matching one to the other, you're losing some properties of one to gain sort of a fit with the other, right? So at least we give you some diagnostics that help you evaluate whether you're doing that in a way that is consistent with some of your other assumptions. So an example of this represented in this chart here might be maybe you've done a roadside survey or a transit survey of a line usage. So you have some survey data represented in red. And at the end of the day, you have some model data that's represented in blue. Well, they don't match very well at all, really, at the end of the day, right? So after you apply these, you can choose which one you want to fit to, and you can choose how closely you want to fit. So in this case, we're going to change our demand to more closely represent what we've matched in the field by observation, and then maybe we're going to scale it to represent the difference between how much we've surveyed and what the actual population looks like, right, to get an estimate. So that in a nutshell is sort of our planning and engineering tool set for day-to-day use. If you're a planner at Metro or an engineer at ODOT, you can be using any one or component of these methods, and ideally, multitude of the methods at the end of the day. But how does this fit into traffic management, or can we do more with this than just plan capacity or improvements for a new facility? Can we use this information, this planning level information, to help travelers today, or residents or constituents today? So we've here, this is an outline of what we see as an advanced traffic management center evolving into today. So if any of you have visited the city of Portland or ODOT, some of this is actually happening today, right? Where we have cameras, we have sensors, we're measuring and collecting some level of incidents or other events that are happening in the system. Right, we're checking some of those. Are we using that in any level of planning? All right, are we using that to affect future events? Well, yes, in some cases we are. Right, maybe for the Trailblazers, maybe we have certain plans because we've measured and collected certain amount of data relative to handling game day events or special events. So. Our tool sets come in this recommendation and execute toolbox. So we have technology to forecast or predict not just 20 years from now, but 15 minutes or 20 minutes from now, the traffic state. And the unique thing for us, we feel, is the fact that we do this based on a planning or model-based approach. So we're not just using, looking back through history and trying to find the closest event that matches our event and saying, okay, based on that, what is the future going to look like? So we're connecting with incident conditions. We're connecting to traffic controllers, and we're getting senses or existing conditions from the system, and we're using that to combine that with the model data itself to then predict what the next 5 minutes, what the next 15 minutes are going to look like based on what's actually happening and what we think are the system demands of what needs to happen. So the benefit to the system at the end of the day, though, has to have some execution, right? You have to do something with that at the end of the day. So that's where we would hand off our recommendations or plans to a signal control system, right? They may say, okay, well, we need to change our signal timings right now because we know that it's not configured to handle the demands that are going to happen based on what's happening right now. So we define these two worlds as online and offline. And so the pieces that I talked about a few minutes ago relative to time dynamic assignments and integrating with different data sources is sort of really our offline data, our offline planning model. So what we do to make this system work is to combine this with, these systems are need much more computing resources and speed, right? When we're working at our desk and we're going to evaluate how a freeway or an arterial is going to perform, it's not a big deal to wait 20 minutes or 30 minutes for some computer processing. Well, that's a little too long if we're going to predict what's happening. That time it's already too late. So so we've enhanced our algorithms, and we've built on top of those algorithms so that we have, in fact, the speed to make these calculations and compute these types of things ahead of real time. And of course, the more that they interface with not just receiving information from the system, but we can also then use this to provide information out to the system in terms of variable messaging signs or speed harmonization type applications. So if you drive in the 217 corridor, we're putting up some variable speed messaging signs. Well, those systems can be, in fact, informed by what the traffic demands are going to be ahead of time as they're setting themselves up to respond. And I guess that's the last piece of that. So I guess in sort of simple terms, or how we position this is really as an added or an amplifier to the system to be able to propagate, fill in where we don't have information, and make use of, turn existing information into better quality information at the end of the day. So putting it all together, realize the benefits. So I took this picture off my wall. As I mentioned, this project that I did in Salem, Oregon, which was really the impetus for me to join PTV several years later. And so what I didn't mention, was the fact that we used all of these elements that I've just walked through here today to arrive at this plan, which today is the only plan in Salem that's ever been adopted that actually has a transit bias over auto in any of the planning they've ever done in Salem, Oregon. And we did that by working with their regional travel demand model to sort of help identify and prioritize corridors. We worked within those corridors to figure out what types of treatments would be most effective and where we could gain the most benefits, and then use that process itself to select a corridor to actually evaluate and provide treatments for. So I think this is a really effective method of planning. I think it's, hopefully we're helping people do this more and more every day to make better decisions. And I guess in summary, I would say these approaches and our tools help decision support at each level and across the individual levels. And that's the end of my talk. So I was told I should leave adequate time for questions. So now it's open to questions. Yeah.
You mentioned other companies that have similar and competing softwares. Do you share data with these other industries to make it so you all can improve your product, or is it competition? Who's getting priority from the city levels?
At some levels there's competition, and some levels there's cooperation. So there's the federal government, or FHWA, in some cases tries to institute standards for different vendors to adopt. So for us, we don't have any proprietary format relative to traffic control data, right? We just need the data that's used by the individual signal vendors in the field. Do they all share the same information standards? Yes and no. More no than yes. So.
One of my questions, my first name's Alicia, last name Holloway, is in regards to security. One of the things that, not even just looking at traffic, but an acquaintance came up to me and just said, oh, look, I can find your address and your house and your apartment right there. And you were saying that how these things are available globally. Not that anyone would purposely do some kind of terrorist activity, but that is the realistic aspect that they're able to look at this and get information about traffic and planning, and how to obviously plan something that would be counterproductive to all of your goals to make it more safe and secure.
So yes, but what is your question?
What do you have in place to enhance basically our national security in regards to having this much access to personnel?
I guess what I would say relative to that is you're not going to find a lot of personal information or otherwise in the models that are driving these decisions. But on the other hand, what I would say is, because we are a planning tool, what we give you is the opportunity to test these types of scenarios. So you can test scenarios of data being compromised and havoc being created. Now, that could be even from a tornado or a hurricane or other events. You can use these tools and methods to assess the benefits. So you can use that to plan for what would happen in these types of situations. So it may not prevent that, but at least it would tell you how you might want to respond at the end of the day. Is that?
And when I said first, that was just an example, but in regards to regional, city, specific areas where someone could foreseeably get this information and use it, to work on it.
Yeah, I mean, a lot of these models are based on some level of personal information, and people do agree to provide it at the end of the day, too. Yeah.
My name is Nate Rochester. I'm very interested in how, in the implications of this software on transit development. And I'm wondering, I'm just going to try to piece this together. I think a lot of this is way over my head. But does the multimodal, multi-resolution integration of your software package have a way to account for transit ridership even when the transit provider does not maintain their own counts? Like, as far as the number of people at particular stops and wait time and stuff like that.
Yeah. Mm-hmm. So, I guess what I'd say is really what got us started. What brought us to, I guess, to the U.S. and where we started having the most impact was evaluating light rail transit installations, particularly in regard to how are they going to function in the street with traffic. So once we've screwed up traffic based on running a train through, how can we fix it quickly, as quick as possible? So we consider transit, from an operational level, meaning moving buses and people and station configurations, as well as line ridership from a high level relative to moving people from their origins to their destinations across the city. You always need some level of data to calibrate to, and usually those come from some forms of surveys, and even if you don't have exact information on line by line, the statistical models that we use will estimate ridership by line based on the time dynamics of service and people's departure and arrival times. So I think you were first.
My name's Gregory Kirkland. You mentioned the 217 corridor, and I was wondering what kind of cooperation that you had with, I know you guys are located kind of over in that area anyway, what kind of cooperation you guys had with the implementation of the variable speed limit signs and the full matrix signs and stuff?
Yeah, I would say very little. We certainly did help ODOT develop a simulation model for the corridor that was used to help evaluate treatments like that, as well as other improvements that have been identified for 217. So I think there was one in the far back first.
So one of the reasons Denmark has a very high share of cyclists is because they use modeling for bikes. And I was wondering how that would interact with this, because level of service is not really conducive to biking and walking and prioritizes cars. And so if there's a bikeway, or how can that be used to foster more ridership?
So did I catch your correction right, that you felt like that it's the modeling that is the reason behind why there's higher European cycle use?
I mean, when they do modeling here in Denmark, they specifically look at bikes and modeling for bikes. And I was wondering.
We do the same here. So in most urban areas, they will have a mode choice model that considers, not just auto, and by auto I mean drive alone, or driving with passengers, carpooling, transit usage, as well as walking and biking. And if you're interested, there has been some research done from students here at PSU relative to bike models and choice models for route choice models, and we've actually implemented those for Portland Metro for use here for city planning for City of Portland and a number of other agencies that are pretty aggressive with planning for bicyclists. So, yeah.
Related to that question, might interject. We got an online question. Ask your opinion about the difference of using models like PTV suit in other countries. Do you perceive any difference here in the States versus other, say, European or Asian countries? To give some examples.
Are there? Well, I mean, our tools are used across the world, as I indicated. Certainly, the modeling techniques are a little bit different, from area to area. I mean, in say less developed countries, the modeling techniques and the access to data is a little different, but they still need to show the benefits of the improvements that they're intending to build. So, and as well as in more developed countries, they use a lot of the same frameworks that we're deploying here, in the U.S. as well. Maybe they use different signal controllers or things of that nature, but yeah. Yeah, I think we were in the middle here with the cap. Yeah.
I was just wondering, what's next for PTV, and maybe specifically kind of looking into the future a little bit, do you see any role with connected vehicles or autonomous vehicles, and what might that be?
Yeah, well, our simulation software actually, well, yeah, if you ask me, I'd love to be in the car. Wouldn't it be great to have VISUM in every single car and, simulating, and providing driver information? That's a little more in the future than right now, but we certainly are supporting connected vehicle research and system deployments because we have car-to-car and car-to-infrastructure interactions in the software.
You talked about integrating OpenStreetMap data, and I'm just wondering if your clients have any difficulties with that, or in terms of its validity, and also how you guys tend to think about that a little bit more?
I tend to think of it as a resource. So at the end of the day, the customer has to agree to the terms and conditions to use it, for one. There's no perfect data at the end of the day. So, it really depends on what you're trying to do with it and what your needs are. So, I can tell you with those examples that we did, we supplied one of these networks to ODOT in Salem. We actually gave them a commercial navigation network with transit service and trail data on it, as well as an OpenStreetMap network. So, you think, well, why is that? Well, one, the restrictions that come with the commercial navigation is a little different, so it's not as freely distributable. But the quality of the data is better. So the data is a little more complete when working with the commercial data, but in the case of the open data, they can distribute it and share it more freely. So. Yeah.
When your software is used to model a new project that's going to be built, do you do any follow-up studies on that where it's built?
Before and after studies, yeah. I mean, there's some guidance on how that's supposed to be done, but I'd say that's we typically don't do that ourselves. But in some, if there's a signal retiming study, for example, there should be a before and after study that's done to see whether it's achieved some benefits, but that's not done on every single project, certainly. In transit, there is some guidance that requires some of that before and after study. Yeah. Back again.
When you do modeling for a new apartment building or something like that, do you take into account location? For example, if something's downtown, the number of car trips generated might be less, but other trips might be generated, like biking or walking, versus if something's on 167, it's much more likely to be car trips.
Yeah, so I didn't talk too much about our PTV Vistro software, but that tool set sort of sits between what I would say is our VISUM software and our VISSIM software. And it's specifically designed to address, parcel level development impacts. And so there are, traffic engineering guidelines that come with if you're going to develop an apartment building, it's going to generate so many trips. And so you're going to work with a jurisdictional traffic engineer to determine what the most appropriate rates are, what the corresponding traffic would be. If it's a redevelopment, it may be substituting some level of trips. And certainly, safety impacts, at intersections for crossings and other things, warrant analysis is done as part of that to determine what treatments are necessary. So it's not just traffic operations, but the interfacing of traffic with pedestrians as well and safety. Yeah.
Is that software specifically targeted for transit-oriented development as well?
I would say to the effect that it's looking at the auto impacts and how to quantify those for most of that is related to the developer fees that are associated with putting in a new development. So, right, are they going to require you to put in a traffic signal or widen an intersection or something like that? So, yes, it could be used, but that's not exactly the target market of that software.
Software that people use for transit-oriented systems?
Well, I would say all of our software at different levels can be used to assess those types of developments. Yeah. Let's go in the back first.
I kind of just read out my questions. What's your assessment for the next step for the suite of models that you are providing? My personal question related to this is, what do you think about activity-based modeling? I think the VISUM part is still wasn't forced it, right? But
no. So yeah, well, you know, I mentioned sort of the speed differential required between sort of what I would call our offline or our traditional assignment models and whether they're simulation or equilibrium assignment. I think we still are challenged to add more methods and increase speed in that framework, and I think we will be doing that so that we can support larger and faster simulations. I think relative to activity-based models, we have built-in, we are probably the only built-in activity-based model platform, but it's an aggregate activity-based model platform built in VISUM. So we have the ability to do a 4-step model or a tour-based activity model. You say, well, what are some of the different, your previous question with regard to some of the differences internationally, I think more international models are aggregate-based models. Here in the U.S., we're using disaggregate models for the at least in the activity-based model concept. And we've hooked up interfaces to those programs equally as well, so you can use our system to get time information to, you know, for the schedulers, and then produce impedances and whatnot to iterate through the decision-making process. So I think there's a spot for both. Sorry.
I'm not going to read my name because I said it once, but a prior presentation a couple of weeks ago, one of the ladies that was giving some information on rural locations was indicating that they basically had no way of detecting certain activities, and they were just now starting to get technology in those areas. And my assumption would be that you would still have like these maps of those areas, and that you would be able to theoretically allow commuters to perhaps access that to get information about future road closures, because road closures due to bad weather was a big issue apparently, and they were looking at signals and how to better manage that. And some of the locations didn't have specific rerouting locations, but again, you said something about 15, 20 minutes in terms of real time. If you could get an idea, maybe an hour ahead or something that would notify you that it's very likely that because of the weather, this is not going to be a good idea. These are alternative routes.
Yeah, I mean, in the context that I was talking about here, you know, I was talking about a traffic management center, and it's mostly its interaction with, you know, the system itself, right? The signals it controls or otherwise. But obviously, most of us now run around with these little devices that are, you know, one of the input data sources for all of this information as well. So, yeah, it's pretty plausible that you could be notified if you were to specify that you were going to go to a destination at a certain time, what an incident was. And there's systems that are crowdsourcing type that would already do that, right? I don't know if you're familiar with applications like Waze or other things like that are doing that type of stuff now, just not as informed by the component of what is the traffic going to be maybe in 10 minutes to tell you that you should. It doesn't help when you're already stuck, but you know, if you know, I should go around this now, right? So, yeah. Any other questions?
try new questions from online, students sending questions. Or, I think one that here is that you talked about microscopic, mesoscopic, and microscopic. How do you decide when to use each, and are there any opportunities to integrate those different scopes in the application?
Well, yes, there's plenty of opportunity to interface them. I guess hopefully maybe I didn't do a good job if that's still a question relative to the opportunity to do that. That's really kind of decided or necessitated based on the questions that you're trying to answer, right? I mean, so, it really depends what you need to answer as to what level, how far, how much modeling or analysis do you need to do to sort of provide information, up the chain for a decision maker. So, to me, I think the questions or the decision-making framework come back to that scale. How much area and how much time am I looking at, and what types of tools do I need to bring those together? Got another one?
Yes, thank you. Sure, this is software actually I'm not heard of. How's PTV should differ from Synchro? I'm not sure whether.
Well, I think our overall our suite is much more diverse than Synchro. So Synchro would maybe make up a component of what we do in PTV Vistro, for example. That is a very close competitor to what Synchro would do relative to intersection level of service analysis or signal timing optimization.
I know Metro use VISUM software for their traffic lane modeling. What other MPO using PTV Vision?
There's a variety. Salem, I mentioned. At the time that I did the study down there, they weren't using VISUM, but in subsequent years they have. ODOT uses VISUM for a lot of their modeling efforts. We have New Mexico as a statewide model uses VISUM. There's a number of cities in Washington, so in the Pacific Northwest. Probably our largest user is Philadelphia, which is DVRPC MPO.
Another question from online is, do you have an estimate of the cost and time length for a typical application for example, travel demand or travel simulation suite?
Can you repeat the question? The cost of the tools or the cost of doing the application?
Supposedly both. Yeah, I would think it's probably interesting to know.
Yeah, so relative to our software basically runs in price from about $5,000 to about $40,000, depending on how you combined and the size that you need. And I guess maybe that seems like, if that was coming directly out of your pocket or more my pocket, that would seem like quite a bit. But when you consider that, how many hundreds of millions of dollars did we spend on studying the Columbia River crossing? There was a lot of simulations models built on and used for that evaluation. So in that context, I would say it's cheap, and I wouldn't call the Columbia River crossing your typical study, but you probably range anywhere from $50,000 to $250,000 for these types of studies, that are often done a lot.
In relation to that, I went on the website and saw there's a free trial or something like that for students. Is there any difference between that and the full version, and how long does that actually
Well, you can keep the, if you want the demo version, you could use it as long as you want. You may need to get a new license file, but the big difference is you can't save anything, and it will time out on you after some level of use. But we do have academic versions and Portland State. So here at the university, any of you could get access to any of our products with full capabilities.
ITS lab, for those that in the civil engineering should all have access. For those in the planning program, you can either talk to me if you want to play with any of those software. We do have, I think, a site license here at work. Other questions? Okay, if not, before I actually thank Steve for a very informative talk. Next week we have Professor Ron Houghton to talk about pedestrian safety and counter change. Let's thank Steve again for
All right, class dismissed a little early.
Anyways, but I did have some other questions.
Okay.
Just for